concerns itself with parametric equations. You can see usually it's got a more intimidating looking graph, but it is defined with x in terms of t and y in terms of t. So as soon as you see that, you know it's parametric equations. In fact, this question, it tells you as well. What it goes on to look at is we've got a point P, it lies on the curve, and it has the coordinates 4 root 3, 15 over 2. Part A of this question asks for the exact value of dy by dx at point P, giving your answer as a simplified surd. So as soon as you see exact value, you want to be using no calculator for as long as possible until the very end. And just pay attention to the fact it wants a simplified surd as well. Okay, so I've written down the parametric equations, and it's worth noting how differentiation works with this. It works almost a way of simplifying fractions that have been multiplied together. So if you consider we're trying to find dy by dx, but based on what we've got, we can get differentiated y with respect to t, but we can also differentiate x with respect to t. But if we were to multiply those together, that wouldn't give us dy by dx. So what we actually have to do is take the reciprocal of x differentiated with respect to t. So we end up getting this little bit. So we keep that in mind whilst we're approaching this question, because we're going to start off by looking at differentiating x with respect to t. Now, that's the easier one to go with. You need to be aware of what tan t differentiates to. That's something you just need to remember. So that one differentiates to 4 sec squared t. And then when we differentiate y with respect to t, this one's a little bit more fiddly. But again, differentiating sine 2t, that's something that you need to be fully aware of. This one just turns to 10 root 3 plus 2t. Okay. Now to find what dy by dx is, we are going to multiply those two together. But it's making sure that we multiply by the reciprocal of that first one that we differentiated. So all we can do with that is just divide by 4 sec squared t. Okay. So that is what we need to input our t value in. Well, at the moment, we don't have a value for t. We've got a value for x and we've got a value for y, because that is the point P that gives us our x and y values. You need to make the decision which one you want to use. Either you want to sub the x coordinate into the x equation, or you want to sub the y coordinate in. Just look to see which one you prefer. Personally, I prefer subbing the x coordinate into x equals 4 tan t. So when x equals 4 root 3, subbing that into our parametric equation, you will get a value for t to be pi over 3, okay? Now we have that value for t, we're going to just return to our equation that we have for dy by dx. Now, at the moment, it's a little bit messy because we've got this 4 sec squared t. Ultimately, we just want to put in that, substitute that value for pi over 3 directly in there and put it into our calculator. So we just need to do something to the top and the bottom just to make it a little bit kinder to our calculator. So if we multiply the top and the bottom by cos squared t, it will give us a slightly friendlier version of the equation. Okay? Now that all's left to do is substitute your value for t in. which we worked out to be pi over 3. So putting all that into your calculator, make sure it's in radians mode. You get -5 √3 over 6.